Today, Science Max is all about sound. We bend the power of sound to our will by making the loudest sound we can.
Wait a minute, a subwoofer.
Subwoofer.
Make cornstarch mud dance, glasses break, and things vibrate. It's the sounds of science. Today on Science Max, experiments at large.
Greetings, Science Maximites, and welcome to... Can you hear me? Greetings, Science Max! You can't... Oh, hold on a second.
Greetings, Science... Yeah, that's much better. Greetings, Science Maximites, and welcome to Science Max Experiments at Large. Today, we're going to be talking about sound. Sound is all around us. We use it every day, but what is it really? Sound is energy. Let's say that this is the... No, stay. Stay. Okay. That this spring is the sound of my voice. When I make noise, it travels away from me in a wave. One air molecule vibrates the next, air molecule vibrates the next, and it looks like a wave. And when there's a little bit of energy, the wave doesn't move very much. Science. But when there's a lot of energy, the wave moves a lot. Science! What do we do? What do we do to make sound louder? This is the Science Max theme song. But it's not very loud because the speaker on my phone isn't designed to make super loud noises. So what we're going to do is find ways to make the volume of that song as loud as possible. Here is one way. Take a phone playing some music and put it in a glass. Make sure the glass is empty, of course. Huh? And suddenly, it's a lot louder. Wow! Why this works is one of the things we're gonna be looking at today. So that's what we're gonna do today on Science Max Experiments at Large. We're gonna learn how to make sound louder, as loud as we can. But I'm gonna need an expert to help me. Oh, I know, Michaela from the Ontario Science Centre. She's very smart. All I need to do is go to the Ontario Science Centre and see if she's busy. Yeah, Michaela, it's good to see you.
Nice to see you too.
That was weird. I was wondering if you could give me a hand with an experiment.
Oh, I'd love to, yeah.
It's a sound experiment.
Sounds awesome.
Right on. Okay, we'll take the portal. We'll go back to Science Max headquarters.
Oh, take the portal? Cool.
Haven't you taken the portal before?
No, don't you remember it wasn't working last time?
Oh, well, it's
Is it working?
fixed this time. Yeah, no, it'll be great. Trust me. Here we go.
Whoa. What's going on, Phil? Is everything okay?
Usually when I come through the portal, I land on something or something falls on me or...
Not today. It's your lucky day.
I guess so.
Safe landing.
Safe landing.
Nice.
High five. All right, so let's get started.
Okay, cool.
This is the experiment I want to max out today, Michaela. I know. Pretty impressive, right? No, hold on.
Okay.
So I take my phone and I play some music on my phone and it's louder, right?
Check it out. Phil, you've just made yourself a resonance chamber.
A resonance chamber.
A
Very
resonance
nice.
chamber is what we say when we're trying to describe how the sound is amplified. So if the sound's coming in from one direction, it's bouncing around, not really losing energy. So when more sound comes in, that's amplified, and we hear it a lot louder.
That's cool. So that's what I want to do. Hold on, let me turn this up. That's what I want to do today. I want to max out as much sound as we can get out of the Science Max theme song, which
I'm
is
so excited.
totally awesome. So what else can we do to do that?
Well, there's a couple avenues I'm thinking. Do you want to try something with electricity or without electricity?
That's because with electricity, we're talking speaker systems and
Yeah.
Right. So why don't we do no electricity for now, and then
All
we
right.
can jump to electricity when we feel we've exhausted everything that's non-electric.
Cool. So I was thinking we could try to make a megaphone, because if we have a lot of sound, we could, funnel it in one direction, and then it'll be louder.
Okay.
What do
Yeah.
you
So
think?
the megaphone's pretty easy to make, right? We could just use. In fact, we could use this piece of paper, right?
Yeah, let's try it. What do you think?
I think it's very megaphony. Science taping it up. Okay, ready? Okay. Turn it on. play it. And doesn't sound, but what if I do this?
Hey, there it is. Right on.
Oh,
That song.
yeah? You hear it?
Yeah. Oh, I hear it.
Okay. So that worked pretty well. So.
Oh, yeah, it works. Works well.
So, okay, so this is pretty easy, right?
Yeah.
Megaphone?
Oh, yeah.
So why don't we max this out? Why don't we make a giant megaphone and see if it makes a big difference?
I think it will. Let's do it.
Sounds good. Let's get started. All sound is vibration, but it's really hard to learn about that vibration if you can't see it. I mean, sound is invisible, right? Well, here's a way that you can make sound visible. All you need is some plastic wrap and salt and a bowl, just a regular bowl, and an elastic, like this. So what you do is you take the plastic wrap and cut off a piece just large enough to fit over the bowl, and then use the elastic to wrap around the bowl to keep the plastic tight. Pour some salt on the bowl, and then watch this. Hello, vibrating salt.
The plastic wrap is stretched tight over the bowl, making it like a drum. A drum that's very sensitive to sound vibrations. Your ear works the same way. That's why we call it an ear drum. The vibrations from my voice make the plastic wrap vibrate, and that makes the salt dance.
But there's more. Let's max this out. This is a Chladni plate, and what it is just a piece of metal on a platform that vibrates up and down to a frequency which I can program with this dial here. And when the sound waves vibrate the plate, they can interact in ways that make the sand form interesting patterns. Take a look.
The sounds I'm generating vibrate the plate, make it move like a wave. But when the vibrations reach the edge of the plate, they bounce back and interact with the other waves going the other way. The way these waves interact at different notes is what causes the sand to make these different shapes.
So this is great, but you know what? We can max it out even more. Maxing it out even more. Okay, that's about as much as I can take of that.
So Michaela and I are on a quest to make the loudest sound we can. The first step is to make things louder without using electricity. We've looked at a resonance chamber, and now we're going to make a large megaphone. Sounds can be amplified by bouncing sound waves around in a space. When I put my phone into the glass acts as a resonance chamber. The sound waves bounce around inside the glass, and they combine and stack on top of each other. This makes the sound louder. Resonance chambers are used by musical instruments like an acoustic guitar. The wooden chamber bounces the sound waves around, and the sound waves build on each other to make the sound louder. A megaphone bounces sound waves as well. Instead of going off in all directions, a megaphone makes the sound waves all go in one direction. That's one of the reasons why a megaphone makes sounds louder, but only when it's pointed at you. So will a bigger megaphone work better?
So we've made a larger megaphone, which is exactly the same thing. You just take a sheet and you roll it up, except our sheet was plexiglass covered in paper, and we've taped it together so it stays. And the idea here...
Oh yeah, bigger megaphone. We're gonna vibrate even more of the air inside of here, and hopefully this thing will be louder.
Okay, so you're ready to try it with the phone?
Yeah.
I think first we should try it with our voices, though.
Okay.
Now, what's your favorite season?
Awesome, I can totally hear you. That's amazing. And it would be fall. No, summer. Spring?
Think
It's
about it.
anything but winter.
So the maxed out megaphone worked, but we still had to try it with my phone.
Okay.
Not bad.
Yeah?
Oh yeah. Oh, definitely.
How about now?
No, not so much. Not so much. Oh yeah. No, no.
So that is a
That was
great
cool.
example of non-electrical amplification.
That's right.
Amplified the sounds, no electricity. Okay, high five. All right. Come on, make some noise! sound is vibration. Here, take a closer look. You see? You got... Okay, let's try this again. All sound is vibration. The string of this guitar vibrates, which vibrates the air around it, causing the sound that you hear. Your vocal cords vibrate in your throat, causing you to make a sound. Ah, 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 la, 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 la. Look at this thing. Look at this thing. See how it's shaking back and forth? It's vibrating. Things that make a high sound, they vibrate faster. Vibrating really fast. Things that make a low sound, vibrate slowly. Low. High note, vibrating fast. Fast! Fast vibrating! Slow. And now you know your sound. Everything has a resonance, a note that it vibrates best at. Let's say this fish tank is, well, any container where sound would be vibrating, and the waves of water are actually waves of sound. Now, normally, sound waves will bounce around inside the container, off the walls, and go back and forth like that. And how fast I move this piece of wood is the frequency, or the note, that we're playing. I could vibrate this wood very fast and make a high note. I could move this plank very slow and make a low note. And the waves just bounce around inside the container. But there's a speed I can move this plank where the waves stop going side to side and suddenly get twice as big.
The waves bouncing off the sides of the tank are meeting the waves going in the other direction. But what we end up seeing is peaks of the waves not moving side to side, just going up and down, like you see here.
This is the resonant frequency of this container. So, let's max this out. Say I have a wine glass, and I wet my finger, and I rub it around the rim. It vibrates at a certain note. That note is the resonant frequency of this wine glass. So what would happen if we were to play that note back to this wine glass really, really loud?
And yes, this is something you should not try at home.
This note makes the glass vibrate the most.
Finding the perfect note things vibrate best at is great for musical instruments, but it's not great for this wine glass. The sound waves are causing the glass to vibrate a lot. And because this glass is delicate, it can only vibrate so much before it breaks.
The vibrations were so strong that the glass literally shook itself to pieces.
Science! Sorry. Science! Oh, wait.
Science!
Michaela and I have tried a resonance chamber and a giant megaphone to make sound louder. Now it's time to move on to the next step of the plan, using electricity to help us amplify sound. And that means speakers!
So, speakers that you have at home, 3 different speakers here, right?
Looks
3 different
really busy.
cones.
Yeah, there's a lot going on.
So, what's the deal?
Well, here at the bottom, we have a subwoofer.
A subwoofer.
Subwoofer.
So it's a woofer, the word is woofer,
Yep.
and it's, okay, so it's for dogs, right?
No, a subwoofer is for low notes here in our speaker.
Ah.
At the top here, we have a tweeter.
So it's for birds. It's birds, dogs. So low, let me guess, low notes?
Yeah.
Tweeters, high notes?
High notes. And then we have this guy here in the middle, and that's called your mid-range speaker.
Oh, that's not nearly a cool name. Now we have speakers, we've taken a look at that, but why don't we take one apart,
Cool.
right?
Yeah,
Because
let's do it.
I've got this one here that I spilled juice on, so it doesn't work anymore. So I've kind of taken it apart. So
Cool.
it's got,
Oh, man, that's awesome.
okay, so it's got the cover. That's cool. So what I find interesting is there's the speaker and the wires, right? Because it's electrical amplification. But check this out. This is just a ring to hold that on. And the rest is just an empty box.
We know what that is. Resonance chamber.
That's right. So that's why it's an empty box. So
Let's take this apart too, see what's going on.
So that's the paper cone, right? So that's that's the drum, I guess. It's like the eardrum, the thing that vibrates.
Yes, yeah, this whole thing vibrates.
So this whole thing.
That's for electromagnet. When we turn this on, the electromagnet goes on and off, and it's causing this whole thing to vibrate.
So that's how it works. It's the electricity turning the electromagnet on and off.
Exactly.
And it's on and off and on and off and on and off and on and off. And then it makes it vibrate at certain speeds, right? Hertz. The number of times it vibrates per second is hertz. What we could do is we could max it out with the speaker and plug the phone into the speaker. But this step does not feel like Science Max to me because anybody can do that, right?
Yeah.
You can just turn up your television right now, and that's pretty much the same kind of thing. We need electrical amplification, but maxed out.
Max it up. What are you thinking?
Okay, so I've got a friend, and he's got a stereo system that he built, put together, and what he does is he tours different cities. So he said he'd bring it by Science Max headquarters.
He's gonna bring it here?
We gotta go outside.
We can see this thing.
And it's very loud, so we have to go outside.
When's he coming?
Right now. All right, let's go check it out.
Seeing sound vibrations is fun. This kind of speaker is a special kind. It's called a subwoofer, which is designed to give you the low notes, the big rumbly bass sounds. I tilt the speaker so it's facing up and cover it with big sheets of plastic wrap, which I push into the cone. Then, tape it so it's nice and secure. Then, what you need is some cornstarch mud, which is 2 parts cornstarch, 1 part water. I've got some yellow cornstarch and some blue cornstarch. This experiment works the best with low notes. I'm playing a tone through the stereo that is very low. Here's what happens when I turn up the volume. It's alive! You see, cornstarch mud is a shear thickening fluid, which means when you impact it, it turns solid. So the vibrations from the speaker cone are making the cornstarch mud impact, and that's turning it into a solid. But then it sort of also melts back into a liquid, so you get little columns of cornstarch coming up and falling down again. It's like it's dancing. Whoa! Visual sound waves. Science! So Michaela and I are going to max out sound. To do that, we need a maxed out sound system. This is gonna be amazing. This is gonna be super maxed out sound experiment. This is
so
James,
pumped.
Michaela.
Hey, James, how are you?
Thanks for coming, buddy.
Nice to meet you.
So, tell us about your speaker system. It looks a lot like a vehicle.
This is my audio van. It's got 4 15-inch subwoofers in the back. It's got a whole bunch of power to power it, and I'm glad to be here to let you guys hear it today.
Wow.
So if I have a speaker at home, like a little speaker like this, how many watts do you think that would be?
Somewhere between 15 and 25.
15 and 25 watts.
Yes.
And you've got 4,000.
Yes.
So that's a lot more.
Yeah, quite a bit.
And subwoofers, they play low notes.
Yes.
So is that better when you have a van like this?
With a car audio van like this, you want to play low notes. Like your house stereos and that will play anything from 120 to 200 hertz. I'm playing 20 hertz to about 35 max for you guys today.
So that's like a sort of rumble of
Yes,
thunder,
very
kind
low.
of blah, 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 blah,
Yeah.
where you really feel it.
Yes.
Like a train going past almost.
Oh, that's cool.
So we get our hearing protection on and we try it out. I know what you're thinking. Phil, what's the point of having loud music if you can't really hear it? Because we've gone from listening to music to feeling it. The sound waves are so strong that they have become a physical presence. Michaela's hair flies around because the air from the speakers is creating shock waves. The sound waves are so powerful, they move the air back and forth, which makes Michaela's hair dance all over the place. And my hair, not so much. I'm totally jealous of your long hair.
Yeah, you need to get longer hair.
Okay, hold on. I'll go right.
Okay.
Whoa! Science Mac, experiments at large, super sound! High fives. Okay, ready to go again?
So cool. Yeah, let's do it.
Okay, we go. This episode of Science Max is all about generating electricity.
Where do we get this electricity that we use all the time?
We try to generate as much as we can using human power, plus solar energy, tidal energy, wind energy, and more. All you need to do is
Turn the generator.
all on this episode of Science Max Experiments at Large.
Greetings, Science Maximites. Take a moment and imagine with me, if you will, a time when the only way to light your house was with candles or oil lamps. There was no electricity. That meant no power tools, no video games, no telephones, and worst of all, no TV. Fortunately, we live in a world of electricity. If you've ever lost power in your city or neighborhood, you know how hard it is to get by without electricity, even for one day. But where does it all come from? Where do we get this electricity that we use all the time? We make it. That's the cool thing. And I can show you how to make it as well. Check it out. All you need is an electric motor. Electric motors are pretty simple. All you do is get a battery and you attach it to the electric motor, and that makes it work. There we go. Attached to the battery, it spins. But if you spin the electric motor, it creates electricity. And that's what we're gonna look at today, creating electricity. We're gonna build a wind turbine. But first, you need an electric motor. And you can probably get one from a broken toy. Just make sure that the toy is broken and that the broken part isn't the electric motor.
Here's what you need: index cards or construction paper, scissors, push pins, science tape,
It's the same as invisible tape, except I use this one for science.
a cork, chopsticks, craft sticks, and modeling clay. And remember, all the steps for this experiment are on our website. To begin, cut the index cards into strips and tape down a push pin so it sticks out. Then fold over the index card and tape it together. Then stick the pin into the cork and repeat that step.
If you want as many blades as you can get on your fan, you're welcome to do that.
Next, take your modeling clay and stick the chopsticks in, then tape the craft sticks in between with science tape. Then take the motor and stick the cork on the end, then wedge the motor in between the craft sticks and tape it down so it stays put.
And there you go, a fan that will spin in the wind.
You want to adjust the fan blades so they all face on a bit of an angle. That way they will catch the wind and spin.
There we go. Now when it spins, it will create electricity. I'll show you with this. It's a multimeter. And a multimeter measures little amounts of electric current. There. The hairdryer makes wind, spinning the fan blades, and we are creating electricity. Now, pretty much all electricity that you make comes down to turning a generator. A small motor like this isn't gonna produce a lot of electricity, barely enough to power one tiny little LED, but it's a start. And a good start is all we need, because today on Science Max Experiments at Large, we're gonna look at all kinds of different ways of generating electricity. Plus, I wanna find out just how much electricity one human being can generate. Although one human being is gonna be kinda lonely, I'm gonna need an expert. Oh, I know, Anthony from the Ontario Science Centre. He can help. I wonder if he's busy. Well, come on. Oh, Anthony! Phil? So I was wondering if you could help me with an experiment. I want to generate as much electricity with human power. What do you think?
I think that sounds awesome.
Okay, great. Let's go back to Science Max headquarters.
Is that the portal?
Yeah, don't worry, all the kinks are worked out. this. Where did you end up?
I was in the vents.
Oh, I ended up in the bathroom. All right, well, now that we're here. Okay, so this is what I started with. And this is just, you know, an electric motor, right?
Right.
So you can generate electricity, you spin it. So I figured in order to generate more electricity, you get a bigger generator?
Exactly, yeah. The bigger the generator, the bigger the magnet, the more the copper, the more the electricity.
Oh, well, you know what we should do is we should just get an even bigger one, like a giant one that they use in like in a power plant or something, or?
Not quite. That would be too big for a person to be able to turn. It'd just be impossible.
So you think this is a good size?
I think this is a great size.
Okay, so that's good.
This is called a multimeter. We're gonna hook up the wires. I will do black to black.
Black to black.
The red. And as you turn our generator, we can see just how much electricity we're generating. Okay, so.
Here, you hold on to that.
This,
and
you
I'll
can
turn
start
the
turning it.
generator. Now it's time to play How Much Electricity Did They Make?
2.4 volts, yeah, it's not bad.
Oh, 2.4, yeah, it's not great. That's just enough to power a small LED flashlight. Better keep trying, boys. I got some handles here that we're going to attach to the
perfect.
end of the generator so
Yeah.
we can spin it.
Okay, let's try.
No matter how fast I cranked the large handle, I couldn't make any more electricity than before.
Okay, let's try something else.
But it's a smaller handle.
Perfect, okay, yeah.
That's good?
Yeah, well, maybe it'll let us get more spins in.
Oh, yeah, because I don't have to make as big a circle.
Exactly. Yeah, it's working already. We're up to like 3.5,
Now, how much electricity is Phil making?
4.5.
That's the same as 3 AA batteries. Maybe enough to power a toy car. Still, a long way to go.
Yeah, it's a lot higher with the faster spins. Oh, all right. You okay?
I'm okay.
Maybe we could use like some gears or something like that.
Oh, yes, you know, that's a good idea because this circle that I'm making here, I can only go so fast. So
Yeah.
maybe with gears, you can do 1 circle here equals like 10 circles on the other gear.
Exactly.
Yeah.
Okay, so kind of like the gears on like a bike.
Yeah, the gears on a bike or something like that. A bike! Of course! Yeah, so we get a bike and we attach the back tire to the generator.
The generator, and then you can use the pedals of the big gear to power the small gears.
Okay, great. We'll go get a bike.
Yeah.
Yeah, high five. All right. Oh, right, they're over here. This is a generator. It generates electricity when you spin it. But how does it work? What wizardry is inside? Well, actually, generating an electric current is fairly simple. All you need is 2 things. First, you need a conductor, like this coil of copper wire, and you need a magnet. Now, this is a galvanometer. It measures small amounts of electric current, and I have my copper wire attached to it. Watch as I put the magnet inside the copper. I get a little bit of an electric current, and then I take it out, it goes in the other direction. A little bit going this way, and then I take it out, a little bit going that way. Positive, negative, positive, negative. This kind of current that goes back and forth is called alternating current, or AC. It's the same kind of electricity you have in your house. But here's the cool thing. Watch this. I put the magnet in and I leave it. It goes back to 0. You only get electricity when you move the magnet. All right, so let's create our generator. Instead of starting with a copper coil like this, what if we just had the magnet and we have it staying still, like that, and we move the conductor past it, like spinning? It's good, but not great, because we're only getting a little bit of electricity as it passes. So let's make it more efficient. Let's put in some more magnets. 1 on either side, and 1 on the top. And now when we spin it, it goes past all of these magnets, and every time we get a little bit of electric current. Well, this is how a generator works. If you take an electric motor or a generator apart, you can see there's a coil of copper wires on the shaft, and it spins around like this. And on the inside, there are magnets. So there you go. When you put it together and spin it, you get an electric current. Or if you put an electric current in it, it will spin, just like an electric motor. And that is how a generator works. Anthony and I are trying to create as much electricity as we can using just human power. But so far, it hasn't been going so well. It all comes down to how fast we can spin the generator.
Maybe we could use like some gears or something like that.
In order to get it spinning really fast, we're gonna use a bike. It's just a matter of getting a bike, taking off the wheel, putting it on a stand,
It is now a stationary bike. It'll be even more stationary once we screw it down.
and attaching the generator.
All right, the bike generator. Bike-orator, what should we call this thing?
Bike-nator.
Bike-nomator. I like it. So, okay, let's go over what we've got here.
Okay, so we've got 2 gears. We've got a big one, we got a small one. We turn our pedals, and the big gear turns the small one.
So this is the whole point of this build, is so that we can get 1 revolution here means a whole bunch is spinning there.
Exactly. The more we get here, the more our generator spins, and the more electricity we get. We get tons.
Awesome. And obviously using bike, because you're using your legs.
The strongest muscles in your body.
Awesome. Okay, so now what's with this horn? That is a loud horn.
I know. I tried to warn you.
That is great. I love that.
So Anthony and I hop on and give it a pedal. We pedal as hard as we can, and we produce a pretty good amount of electricity. How much electricity did they produce?
We got up to maybe like 18 there. You did a pretty good job.
That's enough for a power tool, like a drill.
It's good. You know what? This works well, I think, for keeping a good number for a long period of time.
Yeah.
So we can get up to like 18, 20, but it doesn't, we can't really get any higher than that.
Yeah, you know what we need is like one really hard pull, like all of a sudden. That way you can get like a spike.
Yeah, you're right. So it's like instead of putting all that effort into it going for a long time, you put all the effort into one quick motion.
Exactly.
Yeah, good idea. So you wrap a rope around here and then you just pull it.
Exactly.
And that'd be a really fast motion. Spin it really quick and get a very high number.
High spike, exactly.
Okay. You know, we're gonna have to take the bike apart though.
Okay,
All right. Well, it's science.
Okay, cool. So I'll just get.
Oh, you know what? We actually don't have to take the whole bike apart. We just have to take the generator off.
Oh, right. Okay.
Okay,
Hang
cool.
on a sec. I got it.
And maybe we should attach the horn to the next thing too.
Turn it off! It's so loud!
So you want to generate some electricity. But what do you choose to generate that electricity? Hydro? Nuclear? Coal? Solar? Who knows? I do. I know. And soon, so will you. In order to generate electricity, you need to turn the generator. Turn the generator. One of the most common ways to turn the generator is to use one of these. It's a steam engine. Usually they're a lot bigger. You see, you heat the water to boil it and turn it to steam, which works a piston, which turns the generator. Huh? Pretty amazing, right? But what it really boils down to is heating water to make steam. Boil water to make steam to turn the generator. Coal power. Burn the coal to boil water to make steam to turn the generator. Natural gas. That's different, right? Nope. Burn the gas to boil water to make steam to turn the generator. Nuclear power. That's different, right? Nope. It creates heat, which you use to boil water to make steam to turn the generator. Wind power. We don't even need heat for that. Just use the wind to spin the fan to turn the generator. Hydropower. Just pour water across something that spins to turn the generator. No matter what, making electricity always comes down to turning the generator. It's always yada yada, yada yada, turn the generator. Except for solar. Solar does not work like that. But other than that, it's always yada yada to turn the generator. And now you know your electricity generation. Hey, Ramona, you wanna come and give me a hand over here? My arm is getting tired.
Whew, it is hot out here. Oh, in order to generate electricity, you need to spin a generator. Most forms of electricity generation work like that, but not solar. Solar panels like this one generate electricity from the sun's energy. So, how do they do it? Well, this is a solar panel. Okay, it's not really a solar panel, I just sort of put this together, but it works the same way. There are 2 plates, and on these plates are electrons. I've got golf ball electrons up here, ping pong ball electrons down here, but they're all the same thing. Now, this happy little fellow is a photon, energy from the sun in handy-dandy particle form. What happens is photons come from the sun and hit the top plate and knock some electrons from one side to the other, like this. And that knocks over some electrons. Now, these extra electrons travel up a wire in the form of electricity, and we can use them to do work for us. Then they change to the other charge, go back, and we start the process all over again. That is how solar panels work. But remember, it only works when there's sun and photons.
Anthony and I are trying to generate electricity using human power. Spinning the generator didn't work too well, but we found if we used some gears, like those on a bike, it worked better.
You know what we need is like one really hard pull, like all of a sudden.
Using gears is a great way to get work done. The good news is there are generators with gears already in them. That means if we can turn the spindle once, the gears inside will spin the coil a lot of times. The only downside, turning the spindle gets harder the higher the gear. Anthony and I attach a spindle and then we wind up the rope, which takes a while.
Okay, so the plan is, it's on a big spool now.
Yeah.
And you just run as fast as you can.
Got it.
And we'll hopefully get as many revolutions as we can, depending on how fast your top speed is.
Okay.
Sounds good?
Sounds good. I can be pretty quick.
Okay, good. All right.
Ready?
On your mark.
Uh-huh.
Get set. Go.
How much electricity did they create? 24 volts.
Actually, not bad.
That's enough to power their own personal scooter. Not too shabby, boys.
We need like a hard pull all at once.
Yeah, from something like really big. So what if we could get like really high, like up there? Could we attach the generator up there? You could jump down from there.
And I would hang on the rope?
Yeah.
Yeah, it's good, but I don't want to jump from up there. Oh, what if we put a pulley up there?
That
and
would
then
work.
the rope goes through the pulley and then back down, and then I jump from somewhere much safer, like just on top of here onto a crash mat or something.
That sounds great.
And that's my full body weight on the rope.
That sounds great.
All right, high fives.
Yeah.
Tidal power in 60 seconds.
By now you know that in order to create electricity, you need to spin a generator. Scientists and engineers are always coming up with lots of new ways to use natural forces of the Earth to spin a generator and create electricity. One of those natural forces is the power of the tides. You see, the water in the oceans doesn't stay still. Every few hours, the water, or the tide, goes out. And then a few hours later, it comes back in. So, if you attach a paddle wheel in the water and attach that to a generator, when the tide goes out, it creates electricity. When the tide comes back in, it creates electricity. That is how you create electricity using the power of the tides. It's water power. In fact, hydroelectricity is also using water power. Do we have time to talk about hydroelect? We don't have time? We don't. Okay, maybe come back.
Hydroelectric power in 20 seconds.
20 seconds? Okay, hydroelectricity comes from water. Hydro means water. So all you have to do is find a place where water pours down from a height. And you can put a generator in there, and ta-da, you're creating electricity with the power of hydro. Ha 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 ha, I did it.
Anthony and I have pulled and pedaled, and now we're going to hang on to the rope and use our whole body weight to spin the generator as fast as possible.
Okay,
Okay.
crash mat. Let me test it out.
Looks good.
Yep, it's good for crashing. So I go up here. Okay, I go up here.
Climb on up. We'll get you the rope. Got your helmet for safety.
Helmet for safety, crash mat for safety. So we have the rope, and it goes up through that pulley, and then back down to our generator with a spindle on it. And as I fall, the spindle will turn.
Exactly.
And hopefully the speed of me falling and holding and yanking it down as hard as I can will be the biggest spike of electricity yet.
That's right. We'll be measuring it on our multimeter.
Okay.
Okay.
Ready?
You ready?
Yeah.
Here we go. 3, 2, 1.
I jump down and my whole body weight pulls on the line.
Oh, that was awesome. That was like our biggest spike ever. That was amazing.
All right, high fives. Biggest spike ever. Is it enough to power my house?
Nope.
How much electricity did Phil generate? Almost 30 volts. How much does he need to power his house? 120 volts. He's still off by quite a bit.
Well, we've learned something. Nuclear,
Wind,
hydro,
solar,
natural gas,
coal power.
It's all great ways to generate electricity.
Yeah.
And human power,
Not so much.
not as good. But human power is more fun.
Yeah, way more fun.
Yeah, so your turn?
Yes.
Okay.
Give me,
You
give
take
me.
the helmet and I'll take the multimeter.
Okay.
And then we'll go and we'll do it again. Okay. Wait, I gotta wind it up.
Electromagnets are magnets you can turn on or off when you want. We build our own electromagnet and see just how powerful we can make it.
It held 100 kilograms.
Plus ferrofluid, wizards, and I tried to get to the North Pole using a compass.
Now that I'm here, I realize it's really difficult.
All on this episode of Science Max Experiments at Large.
Greetings, Science Maximites. My name is Phil, and welcome to Science Max Experiments at Large. At this very moment, half the lab is being held together with the power of electromagnets. Magnet 1 turning off. Electromagnets are a really cool and powerful way to interact with the world. And when I say power, that's because you need power to make them work or not work. Magnetism is an invisible force that has to do with the magnetic fields created by magnets that lets them attract things that are metal or each other. But electromagnetism is a little different. You see, magnets are magnets all the time. It's because of what they're made out of. Electromagnets are only a magnet when you have an electric current going through them, which means you can turn them on or off. Today, we're gonna be building an electromagnet. Oh, that was the wrong switch. Anyway, like I was saying, today we're gonna be building an electromagnet.
You need a bunch of copper wire, a very large nail, or something metal to become your electromagnet, electrical tape, a battery, an on-off switch, wire strippers or a craft knife, and the help of an adult, and finally, something to magnetize, like these paper clips. And remember, all of the steps for this experiment are on the website. To begin, take the copper wire and start at the top of the nail. Leave a little bit of wire sticking out, then carefully start to wrap the wire around the nail. Don't go all the way to the end because you need some metal to turn into the magnet. Instead, when you want to start again, run the wire straight back to the top and start wrapping again in the same direction.
And keep wrapping and wrapping until you get to this. Now, I've used some electrical tape here, here, and here to hold it all together.
Using your wire strippers or a craft knife and the help of an adult, remove the plastic coating from the ends of the wires. Attach these wires to the wires from the on-off switch with electrical tape, or attach them directly to a battery if you don't have an on-off switch.
And ta-da, you have an electromagnet with your on-off switch. All you need to do is take the things you're going to magnetize, turn your electromagnet on, and suddenly it becomes a magnet. Pretty amazing, ha 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 ha. And then you can magnetize to your heart's content. But when you're done, don't forget, you want to turn it off. So that's what we're gonna do today on Science Max Experiments at Large. We're gonna max out the electromagnet. So, where's my lab coat? Oh, there it is. We're gonna see how big we can make an electromagnet. And when I say we, I mean me and an expert. Let's see. Oh, Heather from the Ontario Science Center. She knows her way around magnets. So let's see. Yeah. I wonder if she's busy. Well, let's find out.
And after we're done, I'll need to come back and clean up the giant mess I made in the lab.
Good to see you, Phil.
I was just wondering if you could help me with something. Are you busy?
No, I got time. I got time.
Okay, great, because I'm gonna make a giant electromagnet experiment and I need your help.
That sounds like a lot of fun.
Okay, great. Let's go back to Science Max headquarters.
Oh,
we'll
via the portal?
Yeah, by the portal.
Okay.
You sure? I
Yeah.
know you're hesitant, so I want to reassure you, nothing will go wrong.
Great, okay.
Okay. Oh, hey, we're here.
We're outside.
It's okay, it's
no,
okay.
no,
Don't worry about it.
no,
Don't-
I
no, no.
think
It's fine, it's fine,
definitely.
it's fine, it's fine.
You all right?
Yeah, I was supposed to come in over there, but I came in over here. Oh well. So today, Heather, I want to max out the electromagnet. Turn it on, and it's a magnet.
Pretty good.
And turn it off, and it stops being a magnet. I want to make this into a much bigger, maxed out version.
All right.
So what are some of the things we can do to do that?
Well, actually, if you have a larger battery, one that has a higher voltage, we can try that for sure.
Okay,
that
so
will help.
there are batteries that are 12 volts?
Yes.
We could try one of
Give it
those?
a try,
I think
for
those
sure.
are like bigger, right?
Yeah, bigger, more powerful, absolutely. Now, that's one thing you could do. You could also increase the number of wraps of our coil here.
So how many times we wrap that wire?
Yes, we'll increase that magnetic field, making our magnet stronger.
And of course the nail, which is important because that's the thing that eventually becomes the magnet, right?
Right on, yes.
So what I thought we would do is we would start with a bigger nail.
Oh.
What, right? So larger battery,
Yes.
more voltage, and a lot more wraps of the wire.
Right on, and we have more space for that now, which is smart. Good job.
Great, okay, so we'll get to work.
Great.
Max Historica.
If you've ever seen a compass, you know that the needle points north. That's because a compass needle is a magnet and it points towards the Earth's magnetic North Pole. And I'm using this compass to try to get to the North Pole. But it isn't easy. In fact, scientists knew there was such a thing as the North Pole as far back as the 16th century, but no one was able to actually get there on foot until 1927. You'd think it wouldn't be that hard, right? I mean, the needle points you straight there. Just follow the needle, right? But now that I'm here, I realize it's really difficult. I mean, the wind is incredible and the snow is intense and it's so cold. My hands, yeah. So, okay, we're not really at the North Pole. We were just sort of recreating that. But still, I salute the brave explorers who tried to make it there in the name of science. And I got a sense of it because the wind from the fan and the fake snow was. Okay, everybody, let's pack it up. I mean, that was pretty good. I just didn't know about that other camera.
So, back to our main experiment, where Heather and I are building a larger electromagnet. An electromagnet works like this. When an electric current is traveling through a wire, it creates a magnetic field. If you wrap that wire around something ferromagnetic, that's something made out of a metal that is attracted to magnets, like an iron nail, then it becomes a magnet. You can make a magnet stronger by wrapping more wire, which gives more distance for the current to travel, increasing the magnetic field, and you can also increase the strength of the current. Heather and I start with a coil of 30 meters of wire and start wrapping. And wrapping. And wrapping.
There, the wire is now all done. And remember, if you're doing this at home, do not use a drill unless you have an adult to help you out because drills can be very dangerous. This one goes at a very slow speed, so it was okay. But yes, definitely an adult supervised activity.
Then we attach another on-off switch and make some leads that connect to a 12-volt battery. So, more wraps of wire and more current means the electromagnet should be stronger.
Okay, so we're gonna try this electromagnet and we're gonna pick up this stuff right here.
Great.
Ready?
You ready?
Yeah.
3,
2, 1, go! Is it on?
Yeah.
Wow, it really does, you can't tell it's on, but.
No, but bring it closer and.
Oh yeah, look at that. Okay, we
Not
turn
bad.
it off.
All right.
Let's see if this nail can pick up this nail.
All right.
Ready?
Ready?
Go. Oh. Okay, how about this side? Oh, no. No.
I don't think we're strong enough.
It's not strong enough. I think that we need to max this out even more.
Even more?
Right.
So I'm thinking there are a lot of appliances that use electromagnets, meaning it's already set up, it already has tightly wound coils and high voltage. So we're in a lab here. Maybe do you have old appliances around?
I have parts bins with a whole bunch of stuff. Maybe we could find some electromagnets in those.
Let's do it.
Okay, great. Let's go. All right, pliers, battery, copper wire. Now, if you've already done the electromagnet experiment, here's another experiment that uses all the same materials plus these. Ha! Neodymium magnets, some of the strongest magnets you can get. So, here's what you need.
A battery, some neodymium magnets the same diameter as your battery, copper wire, and some pliers.
So here's what you do. First thing is you put the batteries and the magnets together like that. Then what you want to do is bend the wire so it's touching the top of the battery and goes around the battery and then touches the magnets at the bottom. Here's what that might look like. I say might because you can do any shape you want. I've made a coil here, and if you put it over the battery, you'll see it only touches the very top of the battery and the magnets at the bottom. And if I let it go, it spins. It's a homopolar motor. What happens is the battery sends an electric current through the copper wire, and that turns it into an electromagnet, which is attracted to the magnets at the bottom, and it spins. So now let's max it out. Aha! A D-cell battery, which is larger and, of course, larger neodymium magnets. And you do the same thing. Make a coil that only touches the battery at the top and at the magnet, and ha-ha! It spins! Maxed out homopolar motor. But don't worry, this is not the biggest size we're gonna do. Come on. Maxed out homopolar motor. I have 27 D-cell batteries, a giant copper tube, and a neodymium magnet. So I'm just gonna, and then we get rid of that. Put this down. Okay, so the first thing I do is attach the neodymium magnet to the batteries. And I've got all the batteries taped together here so they'll sort of stand up like this. Huh? Giant stack of D-cell batteries. Okay, now what I do is I take the copper coil. I take the copper coil. I need to get. Okay, hold on. I got this. I just need to get the copper coil there. I did it. Okay, so I take the copper and I put it on top of the D-cell batteries like this, and then I let it go. Let it go. Nope, whoa. Homopolar motor. Okay, so that didn't work. But that's okay. I like it when it doesn't work, because that's science. It's not science if it works perfectly every time. I mean, you gotta have some room for improvement.
Heather and I built a larger electromagnet, but it still wasn't as powerful as we hoped. So now we're searching for parts that came out of an appliance that are pre-built electromagnets.
What about this?
I think that'll do the trick.
Do you think that does look like an electromagnet, huh?
It does, yeah.
And there's a whole big bunch of copper wires coiled on
Coiled
that.
around.
So you think we can use this?
Yeah, let's try it.
Okay, great.
We built the next version of the electromagnet. This one already has the copper coils, so it's just a matter of attaching wires and an on-off switch, and attaching all of it to a 12-volt battery.
Do you think 12 volts will be enough?
Let's find out. I think so.
Try that.
Once we do, it works much better.
Oh, no problem at all.
Ready?
Yep, turn it on.
On.
Whoa, pretty good. Okay, off.
Off.
Neat. In case it was really strong, I have the next step. Horseshoe. Okay, ready? Oh, whoa, that's...
Here.
I can't pull that off. Okay, wait, grab this. Okay?
Work together.
Yep.
So that's passed all of our tests.
Yeah.
This is really strong.
Is there a way to test it further?
In order to test how strong our magnet is, it's as easy as seeing how much weight it'll lift. Heather and I find a metal table.
All right, Phil, so I brought the electromagnet.
Okay.
Just put it right here.
Yep. We add some sandbags for more weight and then attach a scale so we can measure how much weight we're lifting. We use a chain hoist, a simple machine made for lifting heavy things. This one can hold up to 454 kilograms. Want to turn it on?
We're ready?
Yep.
Here we go.
You can read on the scale how much weight is being lifted.
And that scale is going up.
Pounds on this side, kilograms on this side. We keep lifting until...
Oh, okay, so how much did it hold?
It held 100 kilograms.
Oh, that's more than I weigh, which gives me an idea. Come on.
This is ferrofluid. It is ferromagnetic, which means it's attracted to magnets. And I know what you're thinking. You're thinking, it's not that interesting. Well, watch as I put it next to this magnet. Very interesting. And because it's a liquid, it behaves in very interesting ways. Watch this. Unlike most things ferromagnetic, like paper clips or iron filings, ferrofluid is a liquid, which means it behaves in a unique way. The spikes it creates are following the magnetic field lines of the magnet. You can see the magnetic field in 3D. It's even more impressive when we max it out. This is ferrofluid outside of a glass jar. Now, it's sitting in a pool around this electromagnet. And this is a dial which I can use to change the voltage of the electromagnet, making the magnet stronger. Watch this. Changing the current going to the spiral in the middle turns it into a magnet. The more current I put in, the stronger that magnet becomes, allowing the ferrofluid to climb the spiral to the top. And remember, even though it looks all spiky, it's still a liquid. I will demonstrate with my plastic spoon. And watch this. When I turn the magnet off, it stops being spiky. Turn it on. Turn it off. Science.
The Wizard Academy. All you have to do is demonstrate true magic. And you will be granted entry.
Well, Fuzzix, who is the next applicant for the Wizard Academy?
Overwhelmo.
Indeed, it is I, Overwhelmo. And prepare to be overwhelmed. Would you be flabbergastified if I balanced this coin on its end?
Not really, no.
But would you be impressed if I was to balance this coin on top of this coin?
Possibly.
Prepare to be flustered and stupefied. Stupeflustered as I balance 3 coins on their ends on top of this glass.
Well, that certainly would seem like magic. Let us see.
Okay. No pressure, Overwhelmo. You can do this. And now, I say, a magic word. A magic word! Ha 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 ha! And now, you must let me into your academy.
Wait. What's under the cloth?
What cloth? This cloth? Nothing! Oh!
Is that a magnet?
This? No!
The pull of the magnet is what's keeping those coins up. The magnet is just strong enough to keep the coins from falling.
No, this is set dressing. It's just...
It was a good trick, but it's science, not magic.
Well, yes. And you will see! You will see! I will be back! I, Overwhelmo, will return! And I will do such magic that you will need extra socks, because I will knock them off with my magic. You will need at least 2 pairs of socks, maybe 3 pairs of socks.
We can still see you.
No, you can't.
So back to our main experiment. Heather and I have created a very strong electromagnet that can hold a lot of weight,
It held 100 kilograms.
Oh.
which gave me an idea.
All right, you ready?
Let's do it.
Electromagnets super maxed out experiment. We've got,
2 electromagnets, 1, 2.
and those are wired to 2 batteries, which are on my belt, just like this, so that I can carry them around. And we've got a crash mat here because
We need to keep you safe because you're gonna be using these electromagnets to get across this massive beam above us.
that's right. I'm gonna stick to this metal beam and go across with the electromagnets.
Wow.
We hope.
I have faith.
I'm glad you do. I've got helmet for safety, goggles for safety, gloves for safety, but in this case, sometimes the lab coat is more safe and sometimes it's less safe. This time, it will get all caught up, so no lab coat. All right, you ready to go?
I'm ready, let's do it.
Okay.
My goodness. 1.
Okay.
Because each of our electromagnets can hold more than my whole body weight, I can use them to cross the beam. When they're on, they stick like, well, magnets. And when I turn them off, they stop being magnets and I can move them along as I go. Now, this is something you should definitely not try at home.
Come on, Phil. You're almost there.
We did it! Yeah! There you go, Science Max, experiments at large, electromagnets! You wanna go?
No,
You sure?
I'm positive.
Okay, I'm going again. Woohoo!
Crazy.